Hello, everyone. So cast your mind back to last year. I was kind of up here. I think I was actually on next door, actually. And I was giving my talk, Beyond Pester 101, and I talked about the valley of despair and the slope of enlightenment on how software testing is a skill, much like mountain climbing, that can be learned and get better at practice. So we looked at 4 types of tests. We had white box, integration, black box, and characterization tests. And we also looked at how to make your unit test suite as good as it can be. However, I kind of sort of left an elephant in the room, and surprisingly, nobody actually asked me about it. I talked about integration unit tests, but I didn't talk about full stack or acceptance tests. So, why did I leave them out? Quite frankly, they are really hard to do and to do well. I didn't really have enough time to go through them because it's quite a large subject. So today we're going to be talking about acceptance testing, what it is, and what tools we have. Unfortunately, I've got a lot of content to get through today, so if you can hold off your questions to the end, that'll be fantastic. You can also harass me afterwards or tomorrow or the next day as well if you've got any questions. I've got a whole pile of resource slides at the end of this talk. Just making sure. At the end of this talk, so all of my code is on GitHub, it's on my blog, so you'll be able to get to it at the end of this talk, so all the resources are there for you. So before we dive into acceptance testing, we need to answer a very important question. Why do you even test? This is an important question to answer because it's going to guide you to make the compromises and decisions on what to test. And this is doubly true with acceptance testing because due to its complexity, it's vital to know that you're actually testing the right thing. So this is a definition that I like a lot. To reduce the risk that a user will experience an unexpected behavior. And there are 3 very important points in this. And the first is you'll never be able to achieve 0 bugs. But what you can do is reduce the probability or the risk that they're going to occur. It's a risk assessment. Ultimately, your PowerShell scripts are going to be used by a user. They're the people we should most be concerned about because testing is a user-centric concern. And lastly, bugs, issues, faults, they're all behavior that a user doesn't expect. But it does raise some interesting questions. If we, the developers, think something is a bug, but the user expects it, is that actually a bug? If a bug doesn't cause the user to notice it, is that even a bug? And by running a test suite prior to releasing code, we can gain confidence in our code so we can release it faster. One of the disciplines of high-quality code is having really good tests. High-quality code is easy to debug, maintain, and add features to. And also, it's a lot cheaper to fix a bug before it even gets to the user. It ensures that what is created actually does what it's supposed to do. So testing kind of forms part of your documentation or a contract of your project. So we know why testing, so we know why we're testing, but why acceptance tests are so difficult? Why are they such a huge mountain to climb? So if you remember our testing period from earlier, this is an image I adapted from Martin Fowler. So the hare and the tortoise on the left, that will show speed, and of course the dollar signs on the right are showing cost. So unit tests right down the bottom in pink, they're fast and cheap to run. Integration tests in the middle are slower but more expensive to maintain. And on the top are our full stack or acceptance tests, and they are the slowest and most expensive to run and maintain. But interesting, notice how each group gets smaller as we go up the pyramid. So ideally you should have many unit tests, some integration tests, and very few acceptance tests. Why? Think of it as like a quality budget. You've only got a finite amount of money to spend, so you can have lots of unit tests because they're cheap and very few acceptance tests because they're expensive. But acceptance tests, they're slow. They are really slow. For example, at Puppet, we have an SQL Server module. All of the unit integration tests take about 3 minutes to run. Acceptance tests take an hour on a good day. And that's because they're running parallel. If we're running serially, that's about 2 hours. That's a long time. They're also, as I said, they're very expensive to run. So that full test suite, that took 8 2012 VMs, 1 2016, 1 Red Hat VM. Not to mention the disk or the space, memory, and also running at high I/O because you're trying to drive these things as hard as possible. And lastly, the acceptance tests are very complex. So that test suite is testing installing and uninstalling SQL Server in multiple configurations across multiple different versions, running arbitrary T-SQL statements. It takes a lot of effort to even get the VMs into a state to even start your testing. And we don't even do clustering, so imagine if we had clustering in there as well. And then there's the shift left movement in testing, where you want to move testing as close as you can to the person actually writing the PowerShell. Because again, it's much cheaper to solve a problem or a bug at the beginning versus when you give it to the user. And acceptance testing tends to be on the far right-hand side of the spectrum because it's slow and complex. And even when an acceptance test fails, it really doesn't give you an idea of where to even start looking for it. Because the further the test is from the code that you're actually testing, the harder and more painful it is to actually find the bug that caused it in the first place. There are more functions, more abstractions, more things to consider. There's more cognitive load. Because there's more that can go wrong. In unit tests, there's maybe usually one, maybe two things that could go wrong. That's why they're called unit. Integration tests, a couple of things can go wrong, but for an acceptance test, there is a metric shit ton that can go wrong. And here's the kicker. The things that can go wrong may not even be in your own control. Third-party dependencies can be a real problem. For example, Microsoft releasing new versions of PowerShell because PowerShell is now a third-party dependency of your PowerShell scripts. DC resources being released, things like that. And here's a concrete example. So this is from Jenkins, from my job at Puppet, and you can see the 3D2.197 CA is actually the commit SHA of what we're actually testing. So we've got two tests there, and we're testing both exactly the same code. At 11 a.m. at the bottom, test passed. 28 minutes later, test failed, no idea why. We didn't change the code, magically something changed and now our tests are failing. And this can be really hard to diagnose. And then to make things even worse, people don't care. People do not care how hard it is to do acceptance testing. They don't care how hard you try to write high-quality PowerShell code. They care that it worked for you for what they were trying to do. So if they're that horrible, and people don't care, why even use acceptance testing then? And to be honest, it comes down to this. Acceptance tests are the things that are actually close to what a user will experience. They are most accurate. People probably won't use your PowerShell like you would a unit test. You can't reliably mock a user because they work in mysterious and strange ways. And unit integration tests tend to be testing for things that you, the author, know. So a classic example of this is the regression test. My PowerShell used to fail at X, therefore I'll write a test so X never happens again. So this is testing for known knowns or even known unknowns. But acceptance testing, that's testing for the unknown unknowns, the unexpected things, the things you wouldn't consider normal. And unit integration testing can't really help here because these are the difficult problems. So to summarize them, acceptance tests are hard because they're slow, they're costly to run, and can fail in many ways. And they may fail out of our control, and users don't really care. So what can we do to help us surmount these difficulties then? So there are two things we can do. So one, we can think about testing and complexity in a different way. And two, we can change the scope of our acceptance testing to make things easier or less impactful. So firstly, how can we think about things about testing to make our lives easier? So acceptance testings are complicated things. So how can we think differently about complicated things? And fortunately, we can draw on other fields of study to help us here. So this is the Cynefin framework. Has anybody ever heard of this? One hand. Two hands. There's the people I talk to, that's why. So the Cynefin framework was created way back in 1999 by David Snowden. He describes this as a sense-making device, as in how can we make sense of the other system, the system and the people around us. So this framework was released in a paper in 2003, and since then it's been applied to many aspects of software design. And today I'm going to give you a very, 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 very brief tour of the framework and how you can apply it to software testing. So again, this is actually really complex. I've got a whole pile of links about Cynefin. I really highly recommend you go and watch them. Okay. So the framework starts with 4 domains. You have obvious, also called simple, complicated, complex, and chaotic. And this is a tongue twister. So many of you may be thinking, surely complex and complicated mean the same thing. And I certainly did when I first looked at the framework. And this is where we define the two differences. So the framework has complicated and obvious on the right as an ordered system. So this means that cause and effect is known or discovered. For example, I make a change to my PowerShell script, it breaks, therefore it's my PowerShell script, the change that I made that actually broke it. Complex and chaotic on the left are unordered. So cause and effect can be deduced from hindsight or even not at all. So in my Puppet PowerShell module example, the script hadn't changed and yet it failed. There was no cause for the effect. And I never did figure out why it broke. Or my favorite is you run it again and it works. So the big difference between complex and complicated is whether there's an ordered cause and effect. So how does software testing fit in then? So unit tests tend to live down the bottom there in the obvious domain. So the relationship between cause and effect is very clear. If you do X, expect Y. So when we get a unit test failure, we use sense, categorize, and respond to fix it. We see the Pester test output. We then categorize it, the kind of failure it is, for example, a type conversion or an off by one or a null error, and respond immediately by fixing it. In essence, we can see the failure and we know exactly how to fix it straight away. Integration tests tend to live in the complicated domain. So the relationship between cause and effects requires analysis, and there are multiple right answers. And we see this in Pester test output, but we also need the information from which tests pass, and if there are other failures at the same time. We then analyze the data and make a decision on where to start fixing the issue. And this analysis requires expertise and a good knowledge of the PowerShell script and how it works. And this is needed because we're testing how things integrate with each other. Acceptance tests tend to live in the complex domain. So the relationship between cause and effect can be deduced in retrospect. So typically when you see an acceptance test failure, this is what you're going to do. I wonder what happens if I try changing this one thing, and you test it. What happens if I try changing this other thing? And you keep changing things and testing and testing and testing and testing, and then you figure out where the cause and effect is. And then you fix the script or the test so it passes. So this is the probe, sense, respond approach. You prod and poke until you figure out the cause and effect. The last one is chaos. So that's chaos engineering or testing in production. So hopefully you've never run Pester tests which blow production up. If you do, you've got to fix your stuff and then worry about what you did in the first place. So this is all lovely. So how does it relate to thinking differently about testing? So firstly, we can use Pester to write acceptance, integration, and acceptance testing, but the tests themselves are quite different. For example, you don't want to try the same debugging techniques from a unit test as you would to an acceptance test. They're a different domain. They require different things about cause and effect. It's also very likely going to cause you a lot of frustration because I, for one, have tried doing that and it's horrible. Conversely, you don't want to have complex debugging in an obvious domain because sure, it'll work, but it's going to take you a lot longer. If you know how to fix it, then you can do it straight away. Secondly, these are just rough buckets. You can get complicated unit test failures or obvious integration test failures. As you become more and more familiar with PowerShell, you'll find that complicated things become complex, and complex becomes complicated, complicated becomes obvious things. And thirdly, because acceptance tests tend to be complex, they need a lot of debugging information. It's really, really useful. It's much more so than integration or unit tests. So make sure you log as much as possible when you're running your acceptance tests. Now, this is a very iceberg of the entire framework, so I really suggest you go and read more about it. Secondly, we can change the scope of acceptance testing to reduce the scope of failure. So with acceptance tests, we can reduce the scope of testing, then we can reduce the size of what we need to test, which reduces the test complexity, which reduces the test duration, which reduces the list of things that can go wrong. Okay? So for example, we say you have a PowerShell module that works on Windows Server. Do you really need to test it on Server 2012, 2016, 2019, both core and desktop editions? Or perhaps that same PowerShell module could be used in 20 different ways, but only 5 of those are just kind of small variations. Do you really need to test it on 20? Or perhaps you can get away with just those 5. But this is the downside of reducing the scope of your testing. It reduces your testing coverage. Now, this in and of itself isn't a bad thing. Remember my definition of why do I test, that testing is always a risk assessment. And this is also why acceptance testing is difficult, because it requires a more holistic thinking about why you test. And when I say change or reduce your scope, what I really mean is the type of acceptance testing you're doing. So this is an example of all the different types of acceptance tests that you can run. I've deliberately squished it onto the slide so you can't read it very well. This is a list of all possible tests for a distributed application using microservice or mesh architecture. Now, many of you are probably thinking, but Glenn, my PowerShell script is not a distributed app using microservice or mesh. And you're right, of course. And many of these tests may be relevant for PowerShell, but a couple of notes here. Firstly, there are a lot of different types of tests on the left there. Usability, regression, penetration testing. This is just narrowing the scope of testing to one particular concern. So regression testing is only concerned about testing for bugs that you don't want to reintroduce. Penetration testing is only concerned about the security of the application. And secondly, notice that different tests are run in different parts of the application deployment process. We can run tests in pre-production, which is before we deploy our script or app. And we can run tests once the app is deployed into production. And we can apply some of these principles to our PowerShell testing suites. And I'm running a bit early, so if anybody has any questions, you can put your hand up now. No? I'm bamboozling? Excellent. So enough theory. Let's actually write some tests. So again, remember all of my code, all of my examples will be available for you, so you don't have to take pictures, it's all there. So we're going to write a series of tests for a chat network integration. So hopefully many of you are familiar with Poshbot. If not, I can see Brandon right there. By default, it has a Slack backend, which means Poshbot can integrate with the Slack real-time chat API and act like a person talking in a channel. What I did was write a Poshbot backend for Mattermost, which is a self-hosted chat system with an API very similar to Slack. So roughly, this is what the architecture of the network looks like. In the middle there, we have the Mattermost server, and it's hosted in a Docker container and exposes a REST API. On the right there is the Mattermost client, and fortunately the server also hosts a web client, so you can easily interact with it, or you can just use a REST API. And finally on the left there is Poshbot. So that's all written in PowerShell. It can also be run with either PowerShell Core or Windows PowerShell. And then Poshbot uses the Mattermost backend to communicate with the server. So basically the backend is basically acting as an adapter between Poshbot and the server. So the first of the tests we're going to write are going to validate that the Mattermost server is operating correctly. And these are going to be called operational acceptance tests. And the second, we're going to write some user acceptance tests, where we're going to simulate being a user and interact with the bot and expect certain responses. So let's start with the operational acceptance tests. And just a disclaimer, there are many definitions for these terms, so don't take what I'm saying as hard and true. There are many opinions, even the experts disagree here. So we have OAT, which is actually just a fancy way of saying, do I accept that this system is able to be operated and supported as I intended? So OAT is done before you release changes. So for example, I make a change to my DSC configuration script, spin it up, I'll then apply my tests, make sure it works, and then I can actually get those DSC configurations out to production to my servers. So that's testing before release. But many of these tests in OAT are actually useful after you release the changes. And this is operational validation testing to ensure that the system is still in that state that can be operated and supported as intended. And the nice thing about OVT is actually a really good place to start writing acceptance tests. There's no need to set up a virtual machine or load test data. So who remembers the 3 A's of testing? Arrange, act, assert, okay? So in OVT, there's no test arranging, there's just acting and asserting. So for this example, we're going to ask 3 questions. Is the server actually running? Does the server think everything's okay? And are the critical configuration settings correct? So I've actually written 7 Pester tests. I'm not going to show you all of the code. I'm assuming you can all write Pester tests right here, right now. But I'm quickly going to show you the code for is the server actually running. So we have 2 basic tests here to confirm if the server is actually running. First, we run invoke web request from the server, and we expect a 200 response from the server. And secondly, we check that the HTML payload to ensure that it actually has a title of Mattermost. because just because it responds that I'm a web server doesn't mean you're actually hitting the web server you expect. So again, there's no test arranging here, it's just acting and asserting. Query the web server, check the response. So an operational server, you'll see 7 tests passed, yay! On a degraded server, you get 1 test failed because it says it wasn't happy. So we can have some very basic Pester tests and actually verify whether a Mattermost server is operational. But you could also write similar tests for Active Directory or SharePoint or whatever external system you have. And these tests can become troubleshooting guides or part of your disaster recovery process and playbooks. They can replace the manual checkboxing that you have to do during your job. I even saw someone write Pester tests to validate PowerShell AST, so you can actually run them as pre-commit hooks if you really want to. But right now, these are just, it's a very simple file. What if we could package them up and distribute them easily? And this is where operational validation framework comes in. And I think I'm stealing OEF talk's thunder today. So the PowerShell OVF framework provides a way to organize and execute Pester tests which are used to validate operation rather than your feature sets. So what we can do is take our plain Pester files and package them up as a PowerShell module. So first of all, we need a module directory. So for this example, I used example module. Next, OVF needs a directory called diagnostics, and inside there we have simple tests, which are supposed to be basic and not take too long. And then we have comprehensive tests, which, as the name suggests, are more complicated and test things in a more comprehensive manner. And then finally, we can get our Pester test files and set them in either in simple or comprehensive directories. So I put the is the server running tests into simple and the rest of them into comprehensive. And the content of the test hasn't actually really changed. For example, this is the simple test file now. I added a param block at the top of my test so that OVF can manually modify the URL if it's different. And I had to change the text for the describe and the context statements, which I'll talk a bit later why I had to do that. But apart from that, the tests are identical. So now we have OVF, we can use the get operation validation or the invoke operation validation functions. Obviously, if we run get, it's going to list all of the available tests that we can apply. I've just truncated the output here, so trust me, it does actually output all of them, otherwise it'd be teeny tiny text on the screen. And you can also pass in the module path or a path, so it's only look for tests in a certain directory as opposed to everything that's on your system. And then of course we have the invoke invoke operation validation function, which actually just runs the tests. So for this example up here, we ran 7 tests, everything's happy, yay. And the Pester name should actually look exactly the same as the ones we wrote before. So a couple of gotchas that I tripped up when I was converting my Pester test to OVF. A lot of the examples that you'll see around OVF talk about PowerShell module, which implies you need a module manifest file. It's not strictly a requirement for OVF, but if you intend to publish the module to the gallery, you're going to require a PSD1. Secondly, you can only have a single root describe block, so you can only have one in the test. And it has to be text only. You can't put variables in there. I got tripped up on this. So please just use pure text when you're doing it. And lastly, make sure you're actually on the latest version of Operation Validation module, because I wasn't, and I banged my head against the wall so many times. Little did I realize this one that comes in my box is incorrect. So we packaged up our tests. So what? Well, now we can share our tests with others if that's appropriate. Even post them on the PowerShell gallery. You can take your module, you can run it with a tool like Watchman, which then manages running the OVF tests, alerting on failures, and this can become the basis of a monitoring tool. Or you can go full circle here. You can use Poshbot to run OVF tests on demand. So imagine you're doing a storage migration, but you also want to go play golf. You can invoke the migration and test the migration via chat on your phone while hitting golf balls and possibly drinking beer. And this is a picture of a Columbia sportswear person doing this back in 2017. So this can be done and has been done many years before. But we can take this one step further. Those tests I wrote are very similar to compliance acceptance testing, which you can probably guess by the name, is testing that your system complies with a set of regulatory controls. What if I could write tests that only confirm that my system can be operated, but it also complies correctly as well? And that's what Inspector is written for. So how many people have heard of Chef's Inspect product? Oh, that's good. So Inspect is a testing framework written by Chef where you can use human-readable language for specifying compliance, security, and policy requirements. And if you have a look at the example here, if you can read Pester, you can understand this. It has a describe and an if block with an assertion called should. But the power of Inspect isn't actually in the testing syntax. It's the metadata for each test that's very interesting. Because you see, OVF had the right idea. Not all acceptance tests are equal. Some tests are simple, some tests are comprehensive. But when you start talking compliance and regulations like Inspect does, the metadata needs to be far, far richer. So this is an extract from the Inspect documentation. So Inspect introduces a new concept called control, and you can see that at the very top. And this is the audit that the control will be proving. Then we have a whole pile of metadata, so impact, title, description, various tags and references. And then finally down the bottom, in teeny tiny text, we have the actual test itself. That is a lot more information about test than just simple or comprehensive. So let's translate our basic Mattermost test into Inspect format. So this is the before in Pester format. Query the server, expect status 200, and the content contains the title of Mattermost. And after. This is the same test in Inspect format. So we now have a control at the top which says these are critical tests. And these are the two tests down the bottom. Is the server listing on the port and validate the server response. Now in my GitHub repo I've converted all the tests into Inspect format, but I'm sure you can agree this is quite readable and actually looks like Pester syntax you saw before. But unfortunately it's not all rainbows. Inspect requires an installation package, so you can get Inspect either via the Chef DK, or you have to install Ruby on Windows, which is so much fun, and use a gem installation process, and this can be quite painful. Also check the licensing for Inspect because it has recently changed. Secondly, Inspect uses RSpec, but it's not actually RSpec. So if you come from an RSpec testing background, or Pester, because Pester and RSpec are quite similar, learning Inspect can be a bit trickier because many of the RSpec concepts don't exist. And thirdly, even though Inspect and Ruby are cross-platform, there will be spots where Windows isn't supported as well as you would hope. For example, that HTTP request that I did, I hit an outstanding bug, and calling a web server is not supported on Windows Inspect, which seems kind of weird. Now, I know you laugh. This is not unique to Inspect, but it's just something to be aware of with cross-platform tools. And if you want to learn more, go to inspect.io. So what can we do then? What if we extended Pester to have the same Inspect style syntax? And so that's what I did. So introducing Inspecster, or Inspect Pester. So I took the control method and the properties for it, and I added it to the Pester function list, and I also enabled some metadata so I could actually go through the reporting. Again, it's all on my GitHub repo, go there later. So here's that same connection test in Inspector format. Notice we've got the control function at the top with the impact, title, description, and tags, just like Inspect. And then, of course, our lovely Pester test down the bottom. So now we have very rich metadata about our compliance tests. Nice. Not very useful yet, because we need to see that output in a nice, easy-to-read report. So I grabbed the PS test report module from Michael Willis and modified to display all this beautiful metadata that I just put in there. There's a report for a degraded Mattermost server. I know you can't read it, so I'm going to zoom in for you. So we can quickly see at a glance the number of failures and how impactful they are. So we've got 2 failures and we've got 1 high impact failure there. And then we can actually see the individual failed controls. We can see the tag information to make searching easier. And we have clickable URLs that we can use to get background information about the failure. So for example, I'm showing links to the API documentation, so you don't even need to search for it when something goes wrong. But these links and information could also be your CIS standards documentation, or a link to a SharePoint site with your auditing information. You can put whatever information you need to help you to diagnose a compliance failure right there. So imagine there's possibilities that opens up for your auditing and compliance reporting. So that's a lot of information to take in. So OAT and OVT are similar, but occur in different software lifecycle. Thinking more broadly around validation testing means going beyond writing tests for right now, but by sharing and packaging them up, it means we can use them collaboratively in things like dashboards and chat ops. We can move from does the system work to does the system comply by using compliance testing tools and automation. And we can look outside the Pester and PowerShell world for examples on how to do acceptance testing differently. We can take their lessons and then apply it directly to Pester. Sounds good? Yes is the answer. Thank you. Yeah, testing is so much fun. All right, so let's move on to UAT. So user acceptance testing, or UAT, consists of the process of verifying that the solution works for the user. Not that the system works correctly, but the thing behaves as a user would expect. So in our case of a PoshBot Mattermost backend, the user types a message and a bot should respond appropriately. So remember the 3 A's of testing: arrange, act, assert. Act is sending a message, assert is verifying the message, verifying the response. But what about the first A, arrange? And this is where things get difficult. In order to test a response to a client message, we need to set to arrange some test instances. We need a Mattermost server, somewhere to run our PoshBot backend, and of course, somewhere to run our tests. And Pester is really versatile and a flexible testing framework, but it is not a provisioning framework. And to do that, we'll have to move back into plain PowerShell and somehow structure the execution. So these are going to be the 3 steps. Create the systems under test, so that's the Mattermost server and the PoshBot stuff. Run the tests, and then finally destroy the systems under test. Seems simple enough. How could that be? Yeah, I spent days trying to get this working. I eventually did, and to contrast that, the actual tests themselves took about an hour or so to get right. Doing this provisioning work is hard, and hard to get right, and hard to get consistent. And I can't stress this enough, without it being consistently right, the tests are useless because you will be chasing ghosts, okay? So all the source code for me doing this is on my GitHub repo. It's about 200 lines of PowerShell to do the provisioning. I took a couple of shortcuts. I'm running the PoshBot stuff on my local computer as opposed to doing it in another system. Technically, you shouldn't run tests on your own machine because it's prone to it works on my box. Doesn't work on yours. So interesting side note here, how did I know that my systems under test were actually valid? Because I ran my OVF tests that I wrote previously on my test systems. So you can actually get value again from your OVF, so your OAT and your OAT and OVT tests. So I wrapped all of that up into a single PowerShell script called pre-Pester, and we can create our systems under test reliably now. That's great. Now to get onto the tests. So one of the great things about tests is that I am a user, you are a user. So it shouldn't be too hard for it to come up for some user-based tests. So this is a screenshot of me using Mattermost. You can see I've typed the message, !help. And after a short time, PoshBot responds by adding a white check mark to my message and responds with a new message with all of the available commands that I can do. And it has a starting with the text of full command name. And we can turn this workflow into an acceptance test. So this is the equivalent in the Pester code. First, we get some information about our test user, what channels it has, tokens and things like that. We then craft a message to the Mattermost API submitting the message, !help. We then wait a few seconds and then query Mattermost to give us information about the message I just sent it. And now we can actually start our assertions. So that little tick box, that was a message reaction. So we can check that the updated message actually has at least one reaction, and that message is what we expect, white check mark. Next, we need to make sure that PoshBot responded with the appropriate help text. So we query the Mattermost API and ask for all of the messages after the one I just sent. We assert there should be one and only one additional message, and the message should contain markdown, triple backtick, new line, and then the words full command name. So what we can do is we can convert a manual user experience into an automated test inside of PowerShell. And once you start to see that flow of arrange, act, assert, you can start to see other tests coming out. For example, what if I try to get help from a command that doesn't exist? Well, it should react with a check mark and say, nope, command can't be found. What if I gave too many parameters? Well, it should respond with a red check mark and send me a message that says the command errored. And you can use a similar Pester code that I just showed you for each of those different types of tests that I just went through. But you can go a bit further. What if PoshBot was a private message instead of a public channel? Or what if I had another user who was just continuously putting out gibberish at the same time? Would my PoshBot actually respond correctly at the same time? So we created our systems on the test. We've written our user tests. Lastly is cleanup, kill the Docker container, kill the PoshBot process. Fairly straightforward. So we have to wrap this whole thing up together now into one basic, one testing PowerShell script. So step 1, inside the try block, we run our pre-Pester script, which provisions the Docker container. Step 2, we run the Pester tests. Step 3, we then trash all of our systems under test. And then step 4, we just exit with the PowerShell with the number of tests that actually failed, because that's kind of a useful number to use when you're using automated systems. So now we have an automated UAT suite, which we can run whenever we're making changes. Now, wouldn't it be nice if we had a framework that would make our lives so much easier here? I mean, surely provisioning Docker containers is a solved problem. And sadly, this is not the case in PowerShell land. The closest we could get was maybe Chef's Test Kitchen product, and I had some issues trying to get that working, and you can come and see me afterwards. I think my use case was a bit outside of what Test Kitchen could do. So if you want a new side project, I highly recommend you write a generic automation acceptance testing framework in PowerShell. If you've got a few 5 minutes, you can go do that for me. So I've gone through writing some OAT and UAT tests, but what are some other ways of thinking differently about acceptance testing to make our lives better? Why confine ourselves to the Pester syntax? Wow, I've got so many tongue twisters in my talk. Yeah. The Pester module has support for using the Gherkin testing language. Does anybody actually use Gherkin? Knows what it is? Oh, wow. You can learn some stuff today. So let's quickly show you what this looks like. This is the UAT test we just wrote, and I've deliberately squeezed it onto the slide. This is the equivalent in Gherkin. This is so much easier to read and understand exactly what you are testing. This is the feature and some background information, and then a plain English description of what we're going to test. So it's when sending a message of exclamation help and waiting 2 seconds, then the message should have a reaction of white check mark, and PoshBot should return a message of blah. This is executable text. This is not just a text document. Pester executes this text right now. If you want to change the delay from 2 to 5 seconds, what do? You just change that to waiting 5 seconds. That's it. You don't have to go hunting through the code looking for start, sleep, or pause, or whatever. You can focus on the behavior of the test, not how you test it. So remember those other examples I showed you? We could actually write them in Gherkin right now. So at the top is a screen grab of me testing manually, and below is the equivalent in Gherkin. I can write what I want to test first, and then focus on how to write that in PowerShell, implement it later. So separating from behavior from implementation of the test. Now don't get me wrong, this does require some extra effort to set up, and Gherkin tends to be far more useful in acceptance and possibly integration testing. But remember back to the Cynefin framework, acceptance tests are different than unit integration and may require thinking differently about our testing language. And thinking differently about how you describe your tests will help you focus on what's important, the user experience. Just for like unit integration tests, not all acceptance tests are equal. We saw this. Oh, look at that. I've doubled up my notes. Okay. I went through test tiering in my Beyond Pester 101 talk. I'll give you the short version. You can categorize your tests according to how important they are, and then run the most important ones first. You get faster feedback with no loss in coverage. So if you want to go back to my Pester 101 talk, watch that and explain in much more detail. Like I said earlier, when acceptance tests are hard to diagnose, so to combat this, make sure you have a broad range of instrumentation on how your scripts or modules or whatever are functioning when under test. So here's an example. In my PoshBot module, I should really take a copy of the PoshBot log before I destroy the Docker container, so that way if a test has gone bad, I can at least go through the log and actually verify what happened. And it's even useful to even grab that log even when nothing broke, because that represents what success looks like. You can then compare the success and failure and see what went wrong. Also, remember to always have timestamps in your logs so you can correlate events, preferably UTC, because time zones are a thing. And to be honest, this is no different than your SCCM or when AD goes wrong. You go and look at the logs. That's the first thing you do. Also, structured logs are far better than free text. PoshPort uses a CSV format. It's much easier to parse and search those logs later on than just random text being splattered into a file. And finally, your local acceptance tests should be automated and run in the same manner that you would on a remote system like Azure DevOps Pipelines or Appveyor. So this means, firstly, if you want to run your acceptance test, you don't need to depend on a shared limited resource like Appveyor or Azure DevOps. You can just do it on your local machine. And secondly, if you run them locally, then you can easily try out new things. You can add new features, try new ways of doing things, and you'll have a high confidence that they'll pass once they go up to the remote systems. You do all have an automated pipeline, don't you? Yes, no. Get one, okay? You need an automated pipeline. So we've come to the end of my talk, but it's not really the end. Acceptance testing is a complex beast and requires you to think differently about processes and failure compared to integration unit tests. You need to instrument our tests differently, realize that test failures may be out of our control, but these tests can give us significant value and confidence that our users will not see unexpected behavior. Confidence that you make changes easily, confidence that you can deploy safely, and confidence that you won't break stuff. So I showed examples of OAT, OVT, and UAT in the real world using some modern tooling like Docker, and how we can take tools outside of the PowerShell world and then apply them into our PowerShell world. But this is kind of just the beginning though. Learning testing is a lifetime software skill, and you can take what you've seen today and apply it to C#, Python, Ruby, TypeScript. This is not just PowerShell. This is the kind of thing that Don Jones was talking about yesterday, taking the time to invest in learning testing, not just Pester testing. And I like this picture because even though she's at the top of the mountain and can't go any higher, the flag says, keep exploring. And I'd like you to keep this in mind when you're looking at better ways to test. Keep searching for those ways to reduce your test suite and still give you the same confidence that your code does what it's supposed to do. So keep exploring the large world of software testing. Thank you.